For this next test, I changed the board a little bit, right? So this is another demo board we have, and I want to show you how to measure switching losses, conduction losses, power efficiency, RdsOn, right? The board that I have there does not have a way of measuring the drain current, so I have no way to measure the drain current and the VDS at the same time, right? So I'll use this board to demo that same feature, right? So what we'll do is we'll use a differential. This is not a gallium nitride board or a silicon carbide. It's a silicon based MOSFET, so it's much slower. So we can use a differential probe and a current probe to make this measurement. Okay, so I have my diff probe, high voltage diff probe, on channel 5 right there, right, and I'll change so it doesn't clip, and we have our current signal on the channel 6, right? So that's our current probe right there, right? And if I put the scaling right, we can actually start seeing the signal. Let's see, there we go, right? And we'll position it right so we can see them at the same time. There we have it, and I'll raise, right? So you can see the current and the voltage at the same time, okay? And we can probably change the trigger as well, so it helps with the triggering part of it. There you go. All right, super. So that's your current, that's your voltage. You can see how they look. I'll make sure it has nicely scaled so it covers a nice portion of the screen, and there we go. Okay, so that's your current, that's your voltage, right? And now we want to measure what is the switching losses, the conduction losses, the RdsOn, right? So this is the best way I've found to do this measurements, right? So usually people use math function or even simulations. The problem with those functions is they have manual errors built in because you'll have to use cursors, right? And using cursors will change measurements every time you do it, because depending on where you put the cursors, the mathematics is going to change, right? So we came up with this software which essentially automates that whole process, right? And all you do is go to measure, right? And you can see all this standard measurements which are known to you generally. We'll go on power right here, and within power I have my channel 5 as voltage source, my channel 6 as current source, right? And what I want to do is I want to measure switching losses, right? So switching analysis. So you can see there is switching losses, dV by dt is di by dt is SOA curve, right? So that's a really interesting one because you can actually measure SOA in real life conditions, not based on data sheet, right? But anyways, I want to focus on the switching loss, right? So if I want to turn on the switching loss, I just click on this guy and then say add, right? And what it does is it essentially, it's trying to calculate it. I don't have enough cycles, so I'll change the scale on this, and there we have it. It's as simple as that, right? And these calculations are usually based on knowing what the switching terminals are, right? Now if I turn on conduction losses, you will see something very different, right? So you see those conduction losses right there, and these conduction losses are based on the currents and voltages that they're measuring in this signal, right? So remember our conversation about the vertical scale. This is where it becomes really, really handy, right? And you can add other measurements, right? So you see RdsOn right there, so you'll measure RdsOn based on what it sees on the signal in this conduction range. You can turn on di by dts, right? And you can pretty much do all the analysis right here, right? So without adding too much to it, I think this is where you can really use this software to make switching conduction losses really easy, and especially for RdsOn measurements, even if you're using GAN and SIG, right? So that essentially concludes our series, right? And if you have any questions or comments, please contact us, right? Or comment in the section below if there is a comment section below, right? All right, this is Seshang signing off. Thank you.
Find out more at Vicom's website.